Today we're doing section 3.1, day 1, and we're going to be discussing different types of word problems you will see in this section. So for the first example, it says the insatiable killer. That's the reputation the gray wolf acquired in the United States in the 19th and early 20th centuries. Although the label was underserved, an estimated 2 million wolves were shot, trapped, or poisoned. By 1960, the population was reduced to 800 wolves. The figure shows the rebounding population in two recovering areas after the gray wolf was declared an endangered species and received federal protection. The exponential function f of x equals models the gray wolf population of the northern Rocky Mountains f of x years after 1978. If the wolf is not removed from the endangered species list and the trends shown in the figure continue, project its population in the recovery area in 2010. So obviously you don't have the model in the picture. It does have a steady incline, and that's also represented by the fact that the exponent is a positive value. So they want us to figure out the population in 2010. So we are going to be subtracting 2010 minus this 1978 because x is measured in years after 1978. So when we do that, we get 32. So we're going to evaluate the function at 32. So I have 1.26. E is a button on our calculator, and then we'll raise it to the 0.247 times 32. So we would obviously use a calculator, so this is something you would practice tomorrow. We would get approximately 412 wolves. So for a problem like that, like I said, I spelled that wrong. You just plug it in, and whatever answer you get is the answer to the problem. Okay, so now let's get into some kind of different types where you have to create the equation. So a quick little recall is compound interest formulas. We went over this last year. So the formula is A equals P 1 plus R over N raised to the NT. And the other formula is A equals P E raised to the RT. So we use this formula when it's compounded continuously. And this formula we use when we have different like compounding, annual, semi-annual, quarterly, monthly. So annual would be 1, semi-annual would be 2. We have quarterly, that would be 4, and monthly, and that would be 12. Okay, and these are going to represent your N values. So let's go ahead and try a word problem. So you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year compounded monthly. The second pays 6.85% per year compounded continuously, which is the better investment. So for both scenarios, our principal will be the same of $8,000. The time will be the same as far as 6 years. What will change in both is there's going to be two different formulas because the compounding is different, and then the R's are going to be different. So let's do the compounded monthly first. So we'll have 8,000, and I'll have 1 plus, I write my interest as a decimal, so 0.07. Monthly is 12 raised to the 12 times 6. So obviously you would type this all in the calculator, and we'll practice doing that tomorrow. And the answer you get is 12,160.84. So we'll always round to 2 decimal places because it's money. The second scenario is compounded continuously, so this is the second formula. So that's where I have 8,000, that's my P, times E, raised to the RT. So my R will be 0.0685 times 6. And when I type all that in, I get $12,066.60. So when you're looking at these two, as far as the better investment, this one would be the better investment. So when we do these word problems, please make sure you indicate, if it asks for the better investment, make sure you indicate which one is the better one. All right, that's all for today.